We cannot possibly take a look at the OSI model without an OSI model to look at, and by golly, here it is from top to bottom: application, presentation, session, transport, network, data link, physical. We can also refer to these by numbers, starting with 1, not with 0, but with layer 1, and layer 1 is the physical layer, and then of course we go up from there. So as network admins, you and I are really primarily concerned with the first 3 layers. We could go a long time in our jobs and not even think about the top 4 layers of the OSI model. We also know that is not going to be the case for your CCENT or CCNA exam, because you're going to need to know a little bit about what these layers do. Knowing the order of them, of course, helps a great bit, and it's going to help you out far beyond earning your CCNA. And we're going to talk about that, but right now I'd like you to take a look at this highly complex diagram I've created for you to show you the application layer in action. And that's not everything you need to know about the application layer, but it's a really good start because this layer is where our end users interact with the network. And this layer also performs some very important behind the scenes tasks, first ensuring that our remote communications partner or partner to be is available. You know, it takes 2 to tango and it takes 2 to network. To have an endpoint-to-endpoint communication, we need 2 endpoints. Also, this layer ensures that those endpoints of any communication, that is, agree on basic rules, including data integrity, privacy, and the presence or absence of error recovery features. And I have a feeling we're going to come back to that more than once in this course. Now, moving down to layer 6. The presentation layer answers one basic question, and it's not going to surprise you to find out that question is, how should this data be presented? It's been a while since this has happened to me, but it has happened to me, and likely to you as well, where you open a PDF with a non-PDF friendly app, or you don't want to spring for a PDF reader, which is free. I don't know, but you're trying to open a PDF with a non-PDF friendly app, and you just get page after page after page after page of unreadable characters. That's a presentation layer issue. Data encryption also takes place at layer 6, and if you're new to that term, that simply means that we're taking some data, plain text data, and we are making it unreadable, but in an orderly fashion. We're going to make it unreadable on our end, then send it, and when it gets to the other end, that other endpoint is going to do something to make it readable. I have a feeling we're going to come back to that encryption topic here as well during this course. Now, layer 5, the session layer, it's a layer you hardly ever think about unless something is going wrong, because the session layer is serving as the manager of the overall data transfer process. And layer 5 handles all 3 of these: the creation, the maintenance, and the teardown of that communications channel, referred to as the session that exists between our 2 communicators. And when it's time to end that channel, that's what the session layer does. It'll tear that session down. Now things start to get interesting for us, the network admins, at L4, which is the transport layer. And the main purpose of L4 is to establish a logical end-to-end connection between 2 systems. Now, that's obviously pretty important, but it's definitely not the only layer 4 action going on. The TCP and UDP protocols, the transmission control protocol and the user datagram protocol, are doing some very important work at this layer. It's important to your network and it's important to your CCNA score, because I would be astonished if you didn't get at least 3 or 4 questions on your exam about TCP, UDP, the differences, the similarities, that kind of thing. It's so important that I have a special section on that later in the course for you. So we will definitely be revisiting TCP and UDP, and we're going to be working with this beauty a lot, because this is where, pardon me, you and I, as those network admins, really start getting involved with things, because we're now at layer 3, the network layer, and that's where we find this little round cylinder type thing with 4 arrows on top, and that is the universal symbol for a router. For those of you new to Cisco exams, you would be expected to know what that is from sight if they gave you a diagram, and certainly you would be able to do that. Now, layer 3 is where routers do their jobs, and basically, very basically, the router's job is to answer 2 questions. What valid paths exist from here, the local router, to wherever we need to go, our destination? And of those valid paths, which is the best path to use to get there? Class over. That's all you need to know about routing, right? Well, it gets a little more complicated as you'd expect, but these are the 2 fundamental questions that a router is answering at layer 3. Moving down one more layer, at the data link layer, we will run into another very common network device that you should recognize on site. This being a box with a 3D box with 4 arrows on top, and this is the universal symbol for a switch, which is our main layer 2 device. Switches are going to use media access control addresses, or MAC addresses, to get their job done. And MAC addresses are often referred to by 4 other names, I kid you not, all of which you need to be familiar with because you're going to see them in books, you're going to see them on your exam, you're going to see them in Cisco documentation, etc. And here are those 4 other names. You'll see it called a layer 2 address or an L2 address, referring of course to the layer at which the address is used. Hardware address, used because the MAC address is physically written into the hardware. And it's really written, it's burned in, which is where we come up with burned in address, or BIA. And then finally physical address, because the address physically exists on a card. Now with the router, we're going to assign IP addresses, and none of those pre-exist on the router, but a switch, and of course plenty of other devices already have a layer 2 address built into their network card. Now, here's the deal with that last one, and be careful with this one because physical addresses do not run at the physical layer, which is the bottommost layer of the OSI model. Physical addresses are just another name for MAC addresses, and they run at layer 2. Speaking of that physical layer, no matter how complex our networks are or how complex they become, what kind of traffic we end up handling years or decades from now, in the end, it is all about sending ones and zeros across the physical layer. I'll even say that to myself once in a while. It's just ones and zeros. It's all ones and zeros. And anytime you see an ad for like a computer course online, or you see them on some book covers, you see all those ones and zeros, that's all it is, and that's at the physical layer. Anything dealing with the network cable or the standards in use, including pins, connectors, the electric current itself, that is running at the physical layer. Now, all of this stuff that our end users are inputting, whether it's documents, whether it's photos, whether it's videos, it's got to be converted to that string of ones and zeros. And that's a pretty formidable task, and it's going to be done bit by bit by bit. You could say literally, because as data flows down that OSI model, the data is gradually converted to smaller and smaller units until we get to the only data unit the physical layer can handle, ones and zeros, right? So let's talk about that, because this is important for you to recognize on your exam as well. Because if they start talking about segments, packets, frames, or bits, you're expected to know at which OSI layer those are going to be found. Now, the application, presentation, session layers, the ones that in our network admin jobs we really don't have a lot to do with, these layers do not have an associated data unit. Data is data, A is A, however you want to put it. Data is just data. It is not yet started to be prepared for transmission. Now at the transport layer, our data unit is segments. At the network layer, we're dealing with packets. At the data link layer, we're dealing with frames, and we're almost there. And then at the physical layer, it's all ones and zeros. We're dealing with bits. So again, just be aware that on your exam, if they're talking about packets, it's L3. You know a router's dealing with it. They're talking about segments, it's a transport layer question. So you got to keep those in mind. Now, as data does head down that OSI model, every layer except the physical layer adds a little bit of overhead. Each layer is going to add a header that will be removed by the same layer at the other end of the session. And these headers are layer specific, because the presentation layer at the receiving end, it doesn't care about any headers on that data except the one that was put on by the presentation layer at the remote end of the session. That's true for every layer. This combination of data and a layer specific header, it's called a protocol data unit, a PDU, and they are usually referred to by the layer number, L7 PDU, L6 PDU, etc. Here's an illustration of what happens. And again, as the data flows down, headers are going to be attached, and that's on their way to the remote endpoint. Note at layer 2, the data link layer, we're also adding a trailer. So that is the only layer with the trailer. That's good stuff to know. And then at the other end of the session, as data flows up the OSI model, each layer removes the header placed there by its counterpart. We are going to take a break right here. Actually, 10 minutes of theory is enough, by golly. We're going to talk about the TCP/IP networking model when we get back, and then talk about how to take these models and apply them, not just for exam success, which is obviously important, but real-world success as well. I'll see you on the next video.